Wall Street analysts are calling it the most disruptive automotive technology in over 100 years. And it's hidden inside Tesla's upcoming Model 2. Picture this. While every other automaker is desperately trying to shave costs off traditional electric motors, Elon Musk has quietly been developing technology so revolutionary that it doesn't just promise a sub-$10,000 Tesla. It's about to fundamentally rewrite the physics of how electric vehicles work. In the next 15 minutes, you'll discover how Tesla's breakthrough Axial Flux motor technology could turn every Model 2 into a mobile power station capable of powering your entire home, while delivering 30% more efficiency than anything currently on the road. We're talking about innovations so advanced that they could reshape not just transportation, but the very infrastructure of how cities consume and distribute energy. Welcome to Tesla Torch, where we break down the latest Tesla innovations that are reshaping our world. If you want to stay ahead of the EV revolution and understand the technology that's about to change everything, hit that like button and subscribe. Because what you're about to learn will completely transform how you think about electric vehicles, energy independence, and the future of urban mobility. Right now, as we speak, Wall Street is obsessed with one burning question that's dominating every automotive analyst meeting. Can Tesla actually deliver a $10,000 electric vehicle that doesn't compromise on performance, range, or safety? The Model 2, which insider sources are increasingly referring to as the Model Q, has become the singular focal point of investor discussions as we head into Q4 earnings season. For nearly a decade, Elon Musk has made bold promises about bringing affordable Tesla technology to the masses, but every attempt has been stymied by the same fundamental economic reality that has plagued the entire automotive industry. Here's the brutal truth that no other automaker wants to admit. Traditional electric motor technology has hit a wall. The radial flux motors that power every electric vehicle on the market today, from the cheapest economy EVs to the most expensive luxury models, are fundamentally constrained by physics and economics that haven't changed since the 1890s. These motors are expensive to manufacture, require complex cooling systems, take up enormous amounts of precious vehicle space, and become less efficient under the exact driving conditions that most people experience every single day. Tesla's competitors have spent billions trying to make these traditional motors marginally cheaper or slightly more efficient, essentially rearranging deck chairs on the Titanic. Meanwhile, Tesla has been quietly developing something that automotive engineers thought was impossible. A complete reimagining of electric motor technology that doesn't just improve on existing designs, but makes them obsolete overnight. The axial flux motor represents the most significant breakthrough in electric motor design since Nikola Tesla himself invented the alternating current induction motor over 130 years ago. To understand why this matters, you need to visualize how traditional electric motors actually work. Imagine a soup can with magnets glued around the inside walls and a copper coil assembly spinning in the center. The magnetic field radiates outward from the center, hence the name radial flux. This design has fundamental limitations that no amount of engineering cleverness can overcome. The copper coils at the center generate heat that's extremely difficult to dissipate because it's trapped inside the cylindrical structure. The magnetic field strength decreases with distance, meaning the outer edges of the coils experience weaker magnetic forces. The spinning assembly creates complex mechanical stresses that require heavy, expensive bearings and precise manufacturing tolerances. Most critically, the geometry limits how much copper you can pack into the motor, which directly restricts maximum power output. Tesla's axial flux motor completely abandons this century-old approach. Instead of arranging magnets in a cylinder, they're positioned on flat discs like pancakes stacked on top of each other. The magnetic field flows axially, straight through the motor along its central axis, rather than radiating outward from the center. This seemingly simple change in orientation unleashes performance improvements that seem almost magical until you understand the underlying physics. The first breakthrough is power density. Because the magnetic field flows straight through flat surfaces rather than radiating outward, every part of the copper coils experiences the same magnetic field strength. This means you can extract maximum power from every gram of copper in the motor. Early prototypes tested by Tesla engineers are reportedly achieving power densities that exceed traditional radial flux motors by 40% or more, meaning you get significantly more horsepower from a motor that weighs considerably less. But raw power numbers only tell part of the story. The real revolution is in how this power is delivered. Traditional electric motors experience what engineers call torque ripple, tiny variations in power output as the motor spins that create vibration, noise, and efficiency losses. Axial flux motors, because of their geometry, produce incredibly smooth torque curves that remain consistent across their entire operating range. This translates to something every driver will immediately notice: acceleration that feels effortless and linear, without the surging or hesitation that characterizes even the best traditional electric vehicles. The efficiency improvements are staggering and directly address the biggest concerns people have about electric vehicles. In real-world driving conditions, particularly the stop-and-go traffic that defines urban commuting, Tesla's axial flux motors are achieving efficiency levels that seemed impossible just 5 years ago. Internal testing suggests improvements of up to 30% in energy consumption during typical daily driving cycles. This isn't theoretical laboratory performance. This is the actual energy savings you'll see reflected in your electricity bill and driving range. The heat management advantages are equally revolutionary. Traditional radial flux motors struggle with thermal management because heat is generated at the center of a cylindrical structure, creating hotspots that are difficult to cool effectively. The motor has to be derated, run at lower power levels, to prevent overheating, which directly impacts performance and efficiency. Axial flux motors generate heat across flat surfaces that can be cooled much more efficiently using simple air or liquid cooling systems. This means the motor can operate at its maximum power output for extended periods without thermal throttling. Think about what this means for real-world driving scenarios: highway merging, sustained mountain climbing, repeated rapid acceleration cycles, or running air conditioning on hot summer days. All situations where traditional electric vehicles experience performance degradation due to thermal limitations. Tesla's axial flux motors maintain consistent performance regardless of operating conditions, delivering the same instant torque on your first acceleration as they do on your 100th. The manufacturing implications of this technology are perhaps even more significant than the performance benefits. Traditional electric motors require incredibly precise manufacturing tolerances because any imbalance in the rotating assembly creates vibration and reduces efficiency. The copper coils must be wound by hand or with complex, expensive machinery, and the assembly process requires skilled technicians and quality control at every step. Tesla has developed revolutionary 3D printing techniques for manufacturing the copper coils used in axial flux motors. Instead of winding copper wire, they're literally printing complex, three-dimensional coil geometries that would be impossible to create using traditional methods. These printed coils can be optimized for maximum efficiency with cooling channels integrated directly into the copper structure. The manufacturing time drops from hours to minutes, and the process can be completely automated. The quality control revolution is equally impressive. Tesla's AI-driven manufacturing systems monitor every aspect of motor production in real time, using machine learning algorithms to predict and prevent defects before they occur. Traditional motor manufacturing relies on post-assembly testing to catch problems, which means defective units have to be disassembled and rebuilt. Tesla's system prevents defects during manufacturing, dramatically reducing waste and production time. These manufacturing innovations could reduce motor production costs by up to 50% compared to traditional methods. But cost reduction isn't the primary goal. The real advantage is scalability. Tesla can ramp production of axial flux motors much faster than traditional motors because the manufacturing process is more automated and requires fewer skilled technicians. This addresses one of the biggest bottlenecks in electric vehicle production: motor availability. Now, here's where Tesla's innovation becomes truly revolutionary. The compact flat design of axial flux motors enables completely new vehicle architectures that simply aren't possible with traditional powertrains. The Model 2 will likely feature in-wheel motors. Individual axial flux motors integrated directly into each wheel hub. This isn't just about saving space, though the space savings are enormous. It's about fundamentally changing how vehicles handle, perform, and interact with their environment. Each wheel becomes an independent propulsion system with its own motor, capable of delivering precisely the right amount of torque for current road conditions. When you're cornering, the inner wheels can reduce torque, while the outer wheels increase it, actively helping the vehicle turn more precisely. When you're driving on slippery surfaces, each wheel can adjust its torque output in milliseconds based on available traction, providing stability control that's far more sophisticated than anything possible with traditional powertrains. The safety implications are profound and go far beyond improved traction control. If one motor fails completely, the other three continue operating normally. The vehicle's stability management system can compensate for the failed motor instantly, allowing you to continue driving safely until you can arrange repairs. This level of redundancy is impossible with traditional single motor or even dual motor configurations. The regenerative braking capabilities are also enhanced dramatically. Each wheel can recover energy independently during braking, and the system can optimize energy recovery based on the specific braking forces at each corner of the vehicle. This means more energy goes back into the battery during every braking event, further extending driving range. The elimination of traditional drivetrain components creates interior space that seems impossible, given the Model 2's compact exterior dimensions. Without a large motor occupying space under the hood, without a transmission tunnel running down the center of the vehicle, and without complex drivetrain components connecting the motor to the wheels, the entire interior can be optimized around passenger comfort and cargo storage. The flat floor isn't just more comfortable for passengers, it enables completely new seating configurations and storage solutions. The center console can be larger and more functional because it doesn't have to accommodate drivetrain components. Rear seat passengers get more legroom because there's no transmission tunnel intrusion. Cargo space is maximized because the rear motor doesn't take up trunk space. This architectural freedom extends to the battery system in ways that fundamentally improve both performance and safety. Tesla's structural battery pack approach, where the battery forms an integral part of the vehicle's chassis, becomes even more effective when combined with axial flux motors. The battery pack creates a rigid floor structure that improves crash safety by distributing impact forces more evenly throughout the vehicle. The lower center of gravity, created by floor-mounted batteries, combined with the distributed weight of in-wheel motors, creates handling characteristics that rival purpose-built sports cars. The Model 2 will likely exhibit virtually no body roll during cornering, minimal weight transfer during acceleration and braking, and steering response that feels immediate and precise. These aren't just performance benefits for enthusiast drivers. They translate to improved safety and confidence for everyday driving situations. The structural integration also enables new approaches to crash protection. The battery pack can be designed with crumple zones and energy absorption characteristics that complement the vehicle's traditional safety structures. In a collision, the structural battery pack helps maintain passenger compartment integrity, while the distributed in-wheel motors eliminate the risk of a large, heavy motor becoming a projectile inside the passenger compartment. Tesla's approach to electromagnetic noise reduction represents another significant breakthrough that will transform the urban driving experience. Traditional electric motors generate electromagnetic noise across a wide frequency spectrum, creating the characteristic whining or humming sounds that electric vehicle owners have learned to accept. This noise isn't just annoying, it represents wasted energy and indicates inefficiencies in the motor design. Axial flux motors, because of their more uniform magnetic field distribution and smoother torque delivery, generate significantly less electromagnetic noise. The magnetic forces are more evenly distributed across the motor structure, reducing vibration and the associated noise transmission into the passenger compartment. Early testing suggests noise reductions of 10 to 15 decibels compared to traditional electric motors, which represents a dramatic improvement in perceived quietness. The implications for urban environments are significant. As electric vehicle adoption accelerates, the cumulative noise reduction from millions of quieter vehicles could transform city soundscapes. Residential areas near busy roads could become more livable. Urban planning could evolve to accommodate quieter transportation, potentially allowing mixed-use development that wouldn't be feasible with traditional combustion engine traffic. But the most revolutionary aspect of Tesla's axial flux motor technology extends far beyond the vehicle itself. These motors are designed from the ground up to support bidirectional power flow, meaning they can consume electricity to propel the vehicle or generate electricity to power external loads. Your Model 2 isn't just a mode of transportation. It's a mobile power station capable of providing electricity to your home, workplace, or even back to the electrical grid. The vehicle-to-home capabilities are immediately practical and could eliminate the need for traditional backup generators. During power outages, your Model 2 can automatically switch to power your home's essential systems: lighting, refrigeration, heating and cooling, internet connectivity, and medical equipment. With a typical home consuming 30 kilowatt hours per day and the Model 2's battery pack likely storing 60 to 180 kilowatt hours, your vehicle could power your entire home for 2 to 3 days without any external charging. The integration with home solar panels creates possibilities for complete energy independence. During sunny days, solar panels charge your vehicle's battery. During evening peak demand periods when electricity rates are highest, your vehicle powers your home using stored solar energy. Overnight, when electricity rates are lowest, your vehicle can top off its charge from the grid if needed. This optimization could reduce your total energy costs while ensuring you always have sufficient range for daily driving needs. The vehicle-to-grid potential represents a paradigm shift in how we think about electrical infrastructure. Imagine millions of Tesla vehicles connected to the electrical grid, each one capable of storing and releasing energy based on demand patterns and pricing signals. During peak demand periods, parked vehicles could automatically sell electricity back to the grid at premium rates. During off-peak periods, they could purchase and store inexpensive electricity for later use. This distributed energy storage capability could help stabilize the electrical grid and reduce the need for expensive peaker power plants that only operate during periods of maximum demand. The intermittent nature of renewable energy sources like solar and wind becomes much less problematic when you have millions of mobile energy storage systems that can absorb excess generation during peak production and release stored energy when renewable sources aren't available. The economic implications for vehicle owners are substantial. Instead of depreciation being the primary economic characteristic of vehicle ownership, your Model 2 could generate revenue through energy arbitrage, buying electricity when it's cheap and selling it when it's expensive. In regions with time-of-use electricity pricing or renewable energy incentives, the revenue potential could offset a significant portion of vehicle operating costs. From a national energy security perspective, a fleet of vehicles with bidirectional power capability could provide resilience against grid failures and natural disasters. During emergencies, vehicles could be rapidly deployed to provide power to critical infrastructure, emergency shelters, or disaster response operations. The distributed nature of this storage capacity makes it inherently more resilient than centralized power generation facilities. The manufacturing and supply chain implications extend far beyond Tesla itself. The traditional automotive supply chain, built around internal combustion engines, complex transmissions, and conventional electric motors, faces potential obsolescence. Suppliers who don't adapt to axial flux motor technology risk being excluded from the fastest growing segment of the automotive market. New supply chains are emerging around the specialized materials and manufacturing processes required for axial flux motors. The 3D printing of copper coils requires different equipment and expertise than traditional motor manufacturing. The permanent magnets used in axial flux motors need different grades and configurations than those used in radial flux designs. Companies that can master these new technologies early will have significant competitive advantages. The workforce implications are equally significant. Traditional motor manufacturing requires skilled technicians for winding copper coils and assembling complex mechanical components. Tesla's automated AI-controlled manufacturing processes require different skill sets focused on programming, monitoring, and maintaining sophisticated production equipment. This transition will require extensive retraining programs and could reshape employment patterns in automotive manufacturing regions. Urban planning and infrastructure development will need to evolve to accommodate vehicles with bidirectional power capabilities. Parking structures could become distributed energy storage facilities, with every parking space equipped with connections that allow vehicles to provide power to the building or sell electricity back to the grid. Shopping centers and office buildings could reduce their electricity costs by utilizing power from parked vehicles during peak demand periods. The implications for developing countries could be particularly transformative. Regions with unreliable electrical grids could benefit enormously from transportation that doubles as distributed power generation and storage. Rural communities could achieve energy independence through combinations of solar generation and vehicle-based storage, reducing dependence on expensive and unreliable centralized power systems. Tesla's Axial Flux motor technology also enables new business models and service offerings. Instead of simply selling vehicles, Tesla could offer comprehensive energy management services that optimize the interaction between your vehicle, home energy systems, and the electrical grid. Revenue sharing arrangements could make vehicle ownership more affordable by allowing Tesla to monetize the energy storage and grid services provided by your vehicle. The competitive response from other automakers will likely accelerate innovation across the entire industry. Companies that don't develop their own axial flux motor capabilities will be forced to license technology or form partnerships with suppliers who can provide competitive alternatives. This could lead to rapid consolidation in the electric motor supply chain as companies race to develop next-generation technologies. The environmental implications extend beyond the obvious benefits of electric vehicle adoption. The improved efficiency of axial flux motors means less electricity consumption per mile driven, reducing the environmental impact of transportation, even as vehicle miles traveled continue to increase. The integration with renewable energy systems and grid storage capabilities could accelerate the transition away from fossil fuel power generation. The Model 2, with its revolutionary axial flux motor technology, represents more than just Tesla's next vehicle launch. It's the foundation of a completely reimagined transportation and energy ecosystem. The technology hidden inside this affordable Tesla could reshape how we think about vehicle ownership, energy independence, urban planning, and electrical infrastructure. The ripple effects will extend far beyond the automotive industry, influencing everything from residential construction to utility business models to national energy policy. As we stand on the brink of this technological revolution, the question isn't whether axial flux motors will transform transportation. It's how quickly the transformation will occur and which companies, communities, and countries will be prepared to take advantage of the opportunities it creates. The Model 2 isn't just Tesla's attempt to build a cheaper electric car. It's the vehicle that could finally deliver on the promise of sustainable, affordable, and energy-independent transportation for everyone. What aspect of this revolutionary technology excites you most? Are you most interested in the performance improvements, the energy independence possibilities, or the potential for completely reimagining how vehicles integrate with our homes and cities? Let us know in the comments below. And don't forget to subscribe to Tesla Torch for more in-depth analysis of the innovations that are reshaping our world. The future of transportation is arriving faster than most people realize, and we're here to help you understand every breakthrough that's driving us toward that future.